Okay, welcome everyone. So today we will start the week second live session on plastic waste management. Okay, so I will start with introducing myself again. My name is Rajarshi Bhar and I am the TA allotted to this 8-week course on plastic management. And currently I am pursuing my PhD from the Department of Civil Engineering in IIT Kharagpur under the supervision of Professor Brajesh Kumar Dubey and Professor Makarand Madhav Bhangrekar. So like the last week's assignment. Today also we have 15 sets of questions along with some solutions, which are also quite easy, but some of them are really important from the examination point of view. We will quickly try to wrap them up within, let's say, I think that can be done in 45 to 50 minutes, not more than that. And in case you have any doubt, any query, or you might be having any points that you could share with everyone here, so please feel free to unmute yourself anytime in between to share your opinion or any doubt, or you can also use the chat box. So, as customary, what I will be doing is after showing each question, we can take a pause of around 30 seconds to 1 minute for you to think about it based on the type of question, and then we will share the answer. Okay, so moving to the first question of today. Which number represents the resin code for polyvinyl chloride? And also, please feel free to use Google Books or anything that you want for looking into these answers. Yes, 3 is the correct answer. So here you can see that there are different types of plastics. PET is 1, HDP is 2, PVC is 3, low density polyethylene is 4, polypropylene 5, polystyrene 6, and then there's some other types of plastics like polycarbonate, acrylics, and all those stuff. They come under the category of 7. So moving to the next question, which are the following statements is or are correct? Option C, that is plastics are both thermally and electrically non-conductive. That is correct. Then plastics are generally resistant to chemicals and corrosion. That is also true. And they are highly durable. That is also true. As a result, option C is the correct answer. So these were the same properties that we covered just now, but still going through some of the other ones. Like they have high strength to weight ratio because a little weight of plastic can provide a lot of strength. After that, plastics are materials with limitless range of characteristics and colors that we all know. Characteristics because people can use it for different purposes, starting from molecule penetration as a membrane, as your biopolymer also, bioplastics are also there for packaging, people use it for carrying stuff. So there are different kinds of uses, sterile, antiseptic, all this stuff. Then, which of the following is a thermoplastic? Yes, option B is the correct answer. So here are some other examples of thermoplastics: polyethylene, propylene, polystyrene, acrylics, Teflon, nylon. These are all thermoplastics because how they are made, they are melted and reshaped when heated and then solidified when cooled. Also, these kind of plastics, the process that takes place, these are reversible in nature. So down the line, we might also face a question where you will have to choose an answer about a similar process, but something that is not reversible. So what will be that type of plastic? So it might come somewhere in today's question. Which of the following is not a property of PET? This is a very simple question. You can just use your general observations for answering it. Okay, option D. Any other options apart from that? You have to choose a property that is not of PET, polyethylene terephthalate. You see, being a plastic, a common idea is that it can be an excellent moisture barrier. That is true. Semi-rigid itself is a type of plastic, which is the nature of PET, and then hygroscopic is in nature or hydrophilic in nature. You have the confusion between these two. So the correct answer for this particular question is option B. That is hydrophilic in nature. That is what I mean to say is PET, it has an excellent moisture barrier, but it is not hydrophilic in nature. It is semi-rigid and also it shows properties of hygroscopic in nature. That means it can absorb moisture from the air. So option B is the correct answer here. So you can see among the lecture slides also it was given that PET is an excellent moisture and water barrier material, excellent permeability, lightweight, semi-rigid, robust, and impact resistant, and also the last point, hygroscopic in nature. So coming to the next question, the plastics that are soft, elastic with low modulus of elasticity and elongation ranging from 10 times their original size are called. यार एग्जाम तोतला है कि जो ओरिजिनल रहते लगभग. Yes, answer B is the correct answer. That is elastomers. Let's see. Here you can see that quickly brushing up the basics definition of soft plastic and elastomer. So the plastics having low modulus of elasticity and the elongation under pressure disappears slowly when the pressure is removed. So such kind of plastics are known as soft plastics, elastomers with the question just explained. Then after that comes rigid plastics, which are stiff and firm and doesn't deform easily. After that, semi-rigid is again something between plastic and rigid. So that's what the name is. It is moderately rigid and stiff, but not very flexible. So some of the examples of these kind of plastics are soft plastic can be LDPE, rigid plastic is polycarbonate, elastomer can be natural rubber or styrene, butadiene rubber. Then semi-rigid plastic is polypropylene, PVC. After that, the next question is what was the increment in the per capita plastic products consumption in India from 2014 to 2017? So this is more like a memory-based question, and it's better if I show you the answer. So you can see here the correct answer is option B. And why is it like that? So this question is framed in a way that can be a bit tricky if you try to answer it very quickly, because you see it asks that what was the increment in the per capita plastic product consumption in India from 2014 to 2017. So by looking at this figure in 2017, you see on top of India there is 11 written. So if you try to answer this question very quickly, you might choose option A as the correct answer, but that is not true, because what the question really asks is you have to select the increment. So increment means what is the addition? So initially it was 9.7 and then it went up to 11. So that means the increment was 1.3. So as a result, option B is the correct answer. So if such kind of questions appear in examinations, so try to be a bit careful while reading the questions so that you don't miss out on some easy marks. Then, which of the following region of India consumes the least amount of plastic as per chemicals and petrochemical statistics of 2030? So which state? We can show you a statistic again. From this particular figure on the right hand side, you can see that the lowest amount of plastic consumption is taking place in eastern India. That is why option D is the correct answer here. So coming to the next question, stabilizers are type of additives added during the production of plastics. Two. So you have to select which one of the four is the role of stabilizers. Okay, so stabilizers are basically used to prolong the life of the polymer by suppressing its degradation. You can understand it with the help of this. So you can see that among stabilizers properties, the first point itself it says that its role is to prolong the lifetime of the polymer by suppressing its degradation that results from UV light oxidation and other phenomena. So that is why option B is the correct answer. And then in the next question, which type of process is used to make plastic sheets from dough consistent thermoplastic mass by passing through a series of heating and cooling rollers? Okay, so answer C is the correct answer. You can see in the next slide, this is how calendering takes place. So this is a plastic dough. It passes on from a hot roller to a cool roller like that, and heats are made out of it. So the next question, which of the following is not an additive used to enhance the property of plastics? So among this, denitrifiers is the correct answer. So you can see here, among the different additives, fillers, plasticides, stabilizers, colorants, lubricants, flame retardants. So these are some of the types of additives being used. And among these, denitrifier doesn't fall under that category. So now coming to some true and false type of questions. Plastics are synthetic or semi-synthetic organic compounds. So you can take around 15 seconds to answer this. So the correct answer is true. Then thermoplastics are generally more expensive than thermoset plastics. That is also true. After that, H2O is used as solvent in the production of cellulose nitrate plastics to dissolve camphor. Now you answer whether this is true or false. So here the correct answer is false. Because mostly when we are talking about plastics, one common thing we need to understand that plastics are not when we are talking about solution or dissolution. So like dissolves like. So H2 is an ionic solvent. So something ionic in nature that can dissolve in H2O. So mostly plastics they often tend to be non-polar. So that is why they rather dissolve in non-polar type of solvents, or organic solvents are used to dissolve plastics. For example, acetone, ethanol. So there is a high probability that these things can dissolve plastics rather than water. Okay, so now thermoset plastics undergo reversible chemical process. So whether this is true or false. So here the correct answer is false, because thermoset plastics, these processes are not reversible, and once done, it can't go back. You can't just again melt it and recast it or mold it. So that is why false is the correct answer. So I will quickly go through all of the questions again, so that those who might have joined late, they can also have an idea. So the number which represents the resin code of polyvinyl chloride PVC is 3. That is option B. Here are some of the other details or other numbers. Then which of the following statements is or are correct? So plastics are both thermally and electrically non-conductive. Plastics are generally resistant to chemicals and corrosion, and plastics can be highly durable. So option C is the correct answer. That is first, second, and first, third, and fourth. After that, which of the following is a thermoplastic? So among these, nylon is a thermoplastic. Then you can see in this list, nylon is there, which is a thermoplastic. After that, which of the following is not a property of PET, polyethylene terephthalate? So here, the correct answer is option B. It is not hydrophilic in nature. Then the plastics that are soft, elastic with low modulus of elasticity and elongation ranging from 10 times their original size are called. So these are called elastomers. After that, what was the increment in the per capita plastic products consumption in India from 2014 to 2017? So you can see here that in 2014 it was 9.7 and it rose to around 11 in 2017. So that is why the increment was 1.3. So option B is the correct answer. Then which of the following regions in India consumes the least amount of plastic as per the chemicals and petrochemical statistics of 2013? So option D, that is Eastern India, is the correct answer. Then stabilizers are types of additives added during the production of plastics to, option B is the correct answer, to prolong the lifetime of the polymer by suppressing degradation. After that, which type of process is used to make plastic sheets from dough consistent thermoplastic mass by passing through a series of heating and cooling rollers? So calendering is the option. After that, which of the following is not an additive used to enhance properties of plastics? Denitrifiers, option C is the answer. Then plastics are synthetic or semi-synthetic organic compounds. True. Thermoplastics are generally more expensive than thermoset. Again, true. And then H2O is used as solvent in the production of cellulose nitrate plastics to dissolve camphor. False. After that, thermoplastic undergo reversible chemical process. False again. So let me just check one thing about camphor. If you Google in which chemicals is camphor soluble, So there you will see, yeah, so camphor is soluble in organic solvents, as we discussed, like ethanol, dimethyl formamide, and some of the other chemicals are also there. And it is very sparingly soluble in water. Okay, so Akash Kumar has raised your hand. So would you like to add something, Akash? Please feel free to unmute yourself. If someone wants to add something or has any doubt or query, please feel free to unmute yourself at any point of time and share that with us. Otherwise, there were few queries raised in the last class on the impact of temperature on microplastics. So I was able to get my hands on some of the research articles on related or somewhat similar fields. So we can take a quick break. Let me see. So we will take a quick break of around 5 minutes and then we will come back to those some of the research articles that have addressed these things. So we can take a 5 minutes break. Okay, so now I will. Okay, so I hope my screen is visible. So this is an article that talks about the impact of warming climate or the climate change, increasing temperature on plastic pollution. So to be very precise, and what it says is that rising temperatures and moisture, it alters the plastic characteristics, which is quite evident. And when I am talking about the rising temperature and moisture, that is not something for a day or two, but something that is taking place for a quite extended duration of time. So now if you want to take a deeper look into it, so here is what we can see in this particular heading, deteriorated properties and increased waste. So what it says is that when we are talking about plastics, so there is a high sensitivity towards your temperature. Why? Because it is a polymer, and as we have already seen, when you heat it up, its elastic properties can vary. It will undergo thermal expansion, and unnecessarily, if you are subjecting a polymer to thermal expansion under various conditions, so it can lead to inferior properties. So one such study was done on polyethylene, PP, and PVC, which experienced that its stiffness decreased by more than 20% when the service temperature of that was raised from 23 to 40 degree centigrade. So from this point, you can imagine that if we want a plastic to be a bit stiff, rigid, so if you are using that plastic in some colder climates, like if we are talking about India, then let's say in some cooler parts of Himachal, Uttarakhand, in those places, as compared to where places in summers like Rajasthan, UP, and most of this belt, which experiences temperatures up to 40 and even higher. So then we will find a significant decrease in the quality of the plastic. So what I said that time dependent changes are also there accompanying the temperature, which makes the mechanical properties of the plastic poorer. On top of that, let me see. Yeah, this is now another example. So in this particular example, for example, when we are talking about packaging, so during packaging, often this is our intention that the plastic should also be a gas barrier, so that the outside gas it doesn't comes into the packaging. That is why when such kind of plastics are subjected to higher temperatures, again here when it was subjected to 40 degrees centigrade, then 75% of its oxygen barrier efficiency was reduced. So this is the kind of impact you can see that temperature can have on the quality of plastic. And once this kind of barrier efficiency reduces, the chances of our food getting spoiled, that also significantly increases. On top of that, like we discussed in the previous session, heat, light, UV degradation, hydrolysis, some degree of biodegradation. So these things can also have a role in microplastic generation. So let me see if we have some other in- interesting points on temperature effect or not. Yes, so another thing that happens, which is quite common, we know that with the rise in temperature, your diffusion evaporation rates also increased. In other words, we can say that entropy increases. So as a result, in warmer climates, there's a chance that the leaching from the plastics can be an accelerated system. The leaching will be faster, so the chance of our contamination of water bodies will also increase and soil. At the same time, during summers, the VOCs or volatile organic compounds from the plastic So that kind of stuff can also be emitted to the atmosphere, even if the rate is slow, but for a prolonged period of time, it can have a significant impact. So these were some of the points. Now, this is another paper which says that warming temperature increases the effects of or worsens the effect of microplastics in a widespread zooplankton species. So zooplankton was the species on which the impact of microplastics with varying temperatures was noticed. So in abstract, whenever there is a paper, whether it is a review or a research article, we often see an abstract there, which can be up to 300 or sometimes 500 words, rarely, but usually up to 300 words. So it kind of gives us an overview of what the paper is doing and sometimes its findings. So you can see here that what it does, let me see. Yeah. So in this study, what was investigated was the effect of environmentally relevant microplastic exposure to this Daphnia pulex species on its survival, reproduction, and growth rate at three different temperatures. So what were the three different temperatures? They were 12, 20, and 24 degrees centigrade. So to simulate these, so how was the study done? So the study was done under artificially exposed temperatures, and the microplastics were created with physicochemical characteristics often detected of those in nature. And then the exposed organisms to concentration close to values other than land. Okay. So the basically the finding was they found that the highest concentration of microplastics significantly impacted survival and total offspring compared to the control at 20 and 24 degrees centigrade, which means they have two conditions. Let's say in one condition at both the temperatures 20 and 24, there was a system with no microplastics, and in another system there is microplastics. So what these researchers observed that the system having microplastic had a significant impact on the survival total offspring when the temperature was 20 and 24 degrees centigrade. But interestingly, it was not the case at 12 degrees centigrade. So at 12 degrees centigrade, the presence of microplastic didn't show a significant impact on the survival of the species and the total offspring. So this was an interesting observation. So if we go to the conclusion part of this study, we might be able to see if they have given some answers. Okay, so basically, if someone wants to have a better idea of what the paper is doing, so the results or the reasons for this observation can also be present. So I will just copy the link of this paper in the Google Meet so that if you are interested, you can take a look later on. Okay. So this is another paper that looks into again interaction of microplastics with cyanobacteria and also the impact of temperature. So let's see what this paper finds. So here what was done is so interactions of environmental relevant concentrations of your high density polyethylene HDPE microplastics. This was the concentration and temperature was 2.5 to 32.5 degrees were evaluated to assess the effect of microplastics on interactions with cyanobacteria's growth, the total organic carbon content in the media, and some of the other enzyme production and microplastic deposition as well. So let's see what their finding was. So it says that when the lower microplastic concentrations were there up to 0.2 milligram per liter, it increased the growth while higher microplastics impeded it across all the temperatures studied. That means if you consider the temperature range, then irrespective of what the temperature is, whether it is less or high, if the concentration of the microplastic is lower, that is below the or within the range of zero point 0.1 to zero point 0.2 milligram per liter, so the cyanobacteria's growth increased, while when the microplastics were at higher concentrations of more than zero point 0.3, then the growth of these bacteria was reduced. What it also says that carbon sources leached from microplastics may have contributing factor to increased growth at lower microplastic contamination. That means like whenever there's a microorganism, so we know that a microorganisms in order to flourish, it needs to have food. And for most of the microorganisms, the common food is carbon. We eat carbon, so similarly microorganisms, many of them, they also require carbon to like for their various metabolic activities. So what this paper suggests is that some of the carbon might have leached from the microplastics when it was there at lower concentration, while when the microplastics were at, and that leached this carbon was used by the cyanobacteria, it is cyanobacteria, right? Yeah, for its growth. But it also says that when the concentration of the microplastics were higher, then the leaching or the presence of microplastic, it had a inhibiting effect on the growth. So apart from that, there could be from apart from the reason that is listed here, so there can be some other possibilities as well for the increased growth of microplastics, sorry, the cyanobacteria. So it has often been seen like people have done studies from our institute and are currently doing that as well. They have seen that when a microplastic is subjected to under different conditions, so the surface of the microplastic, if you imagine it to be a sphere in the beginning, so that sphere, due to various degradation conditions and various pathways, the surface becomes rough, and that rough surface often provides more area for the cyanobacteria or some other microorganisms to deposit and flourish. So that is why there can be another possibility that the rough surface is providing a home for the for these microorganisms to grow. Okay, so we can try to look at some figures here. So you can see, I will enlarge this image. So on the right hand side, this legend is orange color is your zero microplastic. Then there's a color coding of increasing microplastic concentration. On the x-axis, you have increasing temperature, and the y-axis, you have the cell density in cells per ml. So you see one common observation that we have that when the temperature, forget about the microplastics concentration, but when the temperature is lower, at that time, the density of the cells of the microorganism is also lower. As the temperature increased from 2.5 to 10, the number of microorganisms increased, and kind of till 25, it increased almost in a linear fashion, not exactly, but still approximately. After that, there was a decrease. So what it shows is that if I am talking about a certain ambient range, around 25 degrees centigrade, and if we talk about starting temperature at 2.5, so there are various organisms that we know that they love to flourish in your ambient conditions, and when you refrigerate it or drop the temperature, they can't flourish. So similar observation is was seen here. And now, if you focus on the microplastic, so you see at 10 degrees centigrade, this zero microplastic, this is the bar. So in here, the density of microorganisms, it is lower, and as the concentration of the microplastic increased, the cell density, that is the microorganism density, it also increased. Similar is the finding in 17.5 degree also, where the temperature, where the cell density increased till your 0.3 milligram per liter of microplastic concentration, but after that, for 0.4, it decreased. So this is one finding, and then what is this? So this is a photo which depicts the visible difference in the HDPE microplastic deposition of 0.3 milligram per liter with and without exposure to this bacteria. This left hand side, this one is having the microbe and B is not having the cyanobacteria. And the arrow that is given here, it shows the deposited content. So you can see that the tube that which had your, let's say, a bacteria in there, after 28 days, certain amount of microplastics were deposited at the bottom of the tube. So we will try to see what the paper makes out of it. It says that increasing yeah. Since it said that increasing the microplastic concentration significantly increased the deposition, that is what was also illustrated with the help of this diagram. So I will also paste the link of this paper for you to check this out. Like there are many other papers out there for you to explore. So this is one review article on the plastic degradation and microplastic generation under different environments. So on the left hand side, if I go and focus on the thermal conditions, you will see if I will try to go over this particular paragraph. So it is basic science and you will be better able to understand what is happening. So you see here it says that the temperature requirement for the thermal degradation is related to the thermal properties of plastics and oxygen availability. So the glass transition temperature is one temperature Tg and the melting point is another are important thermal properties. The Tg, that is the glass transition temperature, is the temperature at which the polymer transforms from a glassy state to an elastic one. So that is the glass transition temperature. In the polymer, it transitions from a glassy state to an elastic one. On the other hand, plastics are flexible at temperatures above this glass transition temperature, but becomes rigid at temperatures below. Then we have got an activation energy that determines the temperature that initiates the thermal degradation of plastics. Now you see that in the what it says is in the presence of oxygen or in atmosphere in air where oxygen is present, typically what happens is that plastics, which often like most of the times they're all having hydrogen as a constituent, it gives rise to an exothermic oxidation at temperatures close to 200 degrees centigrade and higher. So that means when these plastic they are exposed to oxygen or air, and when you increase the temperature and reach to a point close to 200 degrees centigrade, an exothermic oxidation starts. Oxidation means basically the plastic is getting oxidized, reacting with oxygen, and what happens is an exothermic reaction starts, that is heat is liberated. So that is why we often see that when there is a plastic waste, it is often burnt in various incinerators and the amount of energy derived from it is very high. So now if you want, I can just Google it quickly. Calorific value of HDPE. So you see the calorific value of HDPE granules is 41 to 46 megajoules per kg. That means by burning 1 kg of your HDPE, you can get up to as high as 46 megajoules of energy. Now, if you compare this with coal, coal will most likely have at max 27. Yes, you see the net calorific value of usually coal is around 27 to 31 and then 33. So this shows why the plastics can have very high calorific value because basically under high temperatures there uh, is an exothermic reaction that is taking place and more energy is liberated. So in this paper, there are also various other conditions through which a plastic can degrade. Their photo degradation can take place due to the wavelengths of different wavelengths of light. Mechanical degradation can be due to abrasion when you see a plastic bottle is there. It is rolling down a river. It can like skid over various rocks, pebbles, surfaces. So those kind of degradation can be there. Biodegradation of plastics is also feasible because as you saw in one of the previous studies that we just discussed, cyanobacteria was able to degrade this plastic, or not degrade, I can say, but at least disintegrate or deposit microplastics. So it was changing its physical nature, if not the chemical. But there are also studies which have documented various kind of fungi that are successfully able to degrade plastics. So kind of abiotic and biotic environment can determine how microplastics are generated and at what rate and what is the quality of those. So these were the points that I wanted to discuss in today's live session. I hope that was helpful for you lot, and I will paste this link as well for those who are interested. So this is done, and this one as well. Okay. So now if you have any questions, you can type it in the chat box, or you can also unmute yourself. Otherwise, these were the questions that I wanted to share with you all. And if not, then we can stop the live session now. Like I will be here in case of any questions, but there will be nothing more shared. So the other new questions will be discussed in the next week's live session. Also, just a disclaimer that if you like, since those who have no other doubts, if you want to leave, you can leave at any time. It is not mandatory to join the session till 8, because if there is no one in the session, then I will wait for a couple of minutes and then I will also leave the session.
Sir, good evening, sir. I am Bhargav speaking.
Yes, Bhargav, good evening.
Sir, actually, I am a bit late for the meeting. I just joined. I could not follow the entire session. But
Okay,
last 2 days, 2 days before, I have enrolled this course, sir, and I
right.
have completed my week 1 and week 2 sessions,
Mm-hmm.
wherein a detail about plastic and plastic waste.
Right.
Sir, I am yet to finish my that EPR rules, whatever the week 3 session.
Mm-hmm.
So, sir, now coming to this now, sir, is there any session, sir, for us where what are the recycling methods available out there, where how we can contribute to this preserving this ecosystem, that the damage of done by this plastic can be minimized?
Yeah, that should be there in some of the upcoming classes, like how
Okay,
to deal with this plastic waste, how to manage it, and even if it is not there, then we can have a discussion in it, maybe in the
okay,
extra class that we are going to have. So there
okay.
we can.
Is there any such class scheduled, sir, so far?
Actually, these classes are already recorded and given to NPTEL, so there
Sir.
should be. You can have a look on that. Like there is a syllabus now of this course outline in
Yes,
NPTEL,
sir.
so I think
Yes,
it
sir.
should be clearly mentioned there.
Okay, okay. I will check the week 3 session once, sir.
Right.
And thank you, sir. Thank you.
Oh, well. final time, and then we can call it a day today. In the meanwhile, if you'll have any other final doubts, question, queries, or points, you can always use the chat box or unmute yourself. Right. Let me see if it is visible. Okay, so the first question was the number that is present on PVC. It is number 3. It determines the kind of plastic or polymer being there. Then the properties of these plastics are that they are both thermally, electrically non-conductive. They have insufficient strength to weight ratio. Sorry, this is not correct. They have generally high resistant to chemicals and corrosion, and also plastics are highly durable. So option C is the correct answer. Then which of the following is thermoplastic? So nylon. After that, which of the following is not a property of PET? It is option B, hydrophilic in nature. Then plastics that are soft elastic with low modulus of elasticity and elongations ranging from 10 times their original size are called elastomers. After that, what is the increment in the per capita plastic production? Plastic product consumption in India from 2014 to 2017. So it increased from 9 to 9.7 to 11. So the increment was here 1.3 kg per person. Then, as per the Chemicals and Petrochemical Statistics 2013, Eastern India consumes the least amount of plastic. Then stabilizers are additives that are used in plastic to prolong its life so that the degradation is suppressed. Then, if you have to draw plastic sheets from a dough consistent thermoplastic mass by passing through a sheet of heating and cooling rollers, then the process is called calendering. After that, which of the following is not an additive used to enhance property of plastics? So the option C is the correct answer. That is denitrifiers. Okay, so I will go a bit slower. Then plastics are synthetic and semi-synthetic, or sorry, plastics are synthetic or semi-synthetic organic compounds. So it is true. After that, thermoplastics are generally more expensive than thermoset plastics. It is also true. After that, H2O is used as a solvent in the production of cellulose nitrate plastics to dissolve camphor. It is false. H2O can't be a good solvent for camphor. It is more soluble. Camphor is most easily soluble in organic solvents like ethanol. After that, thermoset plastics undergo reversible chemical process. This is also false. And isopropyl alcohol is a very commonly used flame retardant in the manufacturing of plastic. So this answer is also false. So these were the questions. If you don't have any other doubt, then we can call it a day and pause our live sessions for today and join with some new questions in the next live session. Please let me know if there are any more questions. So I will be here for the next 5 minutes.